Okay, so here's the 2020 paper 2 for Edexcel, and we're now going to have a look at question 1. Here we go. So the first question is going to be about fluid pressure. So if I just put P and an F, and we know that, well, fluid pressure is made out of two parts. We've got the atmospheric pressure above it. Let's put it like that, atmospheric pressure, and because that's the unit for pressure. And then if I'm in, say, a liquid like water, so there's the C, the total fluid pressure is the atmospheric pressure plus the water pressure. We also need to know that pressure equals your depth under the water. So if I just label that as H, so it's the height under the water, or the depth, times by the density of the medium, so seawater is more dense than fresh water, times by gravity, and I said that you need to know that that value is 10. So what can we look at there? Where is the pressure the greatest? Well, it's going to be whichever surface is further below the surface of the sea. And we can see it's this surface here. So that's going to be C. On to the next one. 2 blocks of stone are resting on the bottom of the sea. Both blocks have the same height. So I'm going to circle that, and I now know that is the same height on each, which is going to be important. Area Y is 4 times bigger than area X. Okay, happy with that. And it says, what is the pressure due to the water on the top of the surface of block Y? Well, the crucial part is each of these are the same height. They're each in the sea, so they have the same density, and they're in the same planet, so they each have the same gravity. So it's trying to trick you into thinking about force. So PFA, and it's not asking that. It says, what's the pressure? Well, the pressure on each is exactly the same. They're both the same depth under the sea. They're both in the same medium, and they both have the same force of gravity on them. So it's the same, B. On to the next one. A diver swimming underwater in a lake. They wear the meter shown. State the depth in figure 3. So this is just reading scale. So we can see we've got 6 there. We've got 8 here. And then that's a change of, whoops, that's 8. So that's a change of 2. So each of these is half. So 6, 6.57, 7.58. So that clearly must be 6.5. And it's just checking, can you read scales? And then clearly, can you check that it says meters there? So 6.5 for a mark and meters for a mark. State how the pressure of the water on the diver changes as he swims down from the surface. So as we go further down, we increase that height or the depth that you are, and therefore pressure will increase. So the pressure increases. State why the total pressure on the diver is greater than just the pressure due to the water. So total pressure, so if I put PT, and I'm going to call it total fluid pressure. As we said before, it is air pressure plus water pressure. So what are we missing? Well, we're missing atmospheric pressure. So if we can imagine, there's the diver. Oh my God, swim, 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 scuba thing, let's put a mask on them, bubbly, bubbly, bubbly. There they are, they've had a bad day. But we can now see we've got the fluid pressure, the water pressure acting on them, but we also have the weight of the column of the air above them. We also have atmospheric pressure. So there we go. And those two added together give the total pressure. So you need to add atmospheric pressure. Just remember that number as well, 101,300 pascals or newtons per meter squared. And we've got to add that on. Next part, an aeroplane takes off from the ground. State 2 factors, and they've put it nice and bold for you, and even told you, make 2 points, please. And that also says, make sure they're different points. As the aeroplane goes higher in the atmosphere. Oh, press that with my elbow. So crucial part then, here's the cloud. That definitely doesn't look like a cloud. There's a cloud. There's a cloud. There's my aeroplane. What do we know? We know that there's more air particles below and not very many above. So we know that the density of the air decreases. We know the temperature of the air decreases up there. We know that the atmospheric pressure decreases up there. So 2 factors that affect the pressure of the atmosphere as it goes higher. So Well, the height or the weight of the atmosphere above the plane decreases. And again, we're just trying to link it to this P equals H rho G. So there's less. So at this point here, I've got, let's put that point there. In this point here, I have the weight of all of the particles in the column of air above me. If I'm higher up, I have a lower weight or height. So that's that bit ticked off. Well, the next thing is we could talk about the density. So we know that the density is less because there are less particles, there's less collisions. So the density of the atmosphere decreases. And we can't talk about gravity too much because gravity does not change that far as we go off the surface, but there would be a slight reduction. But what we could talk about is the temperature of the atmosphere decreases. And that will then mean that the particles have less kinetic energy. But I would just say you're sticking to using this formula that's at the back of your booklet, and it's talk about the factors. Anytime I ask you to talk about factors in terms of pressure, go and get the equation and go and see what each of those are. There we go. Question 1 done.